Alrighty, folks, so it's just a minute past the hour, and I think we're going to get started. And as I mentioned, there will be probably people who continue to log in over the next few minutes. So, but we are going to get started just to make sure that we stay on time. So, first of all, thank you everyone who's been able to join us today. This is Christine here with the Canadian Freshwater Alliance. I'm the Communications and Special Projects Lead. I'm based in Kelowna, BC, which is on unceded Syilx Okanagan territory. And for those of you who have not been on a Canadian Freshwater Alliance webinar before, just a quick word about what we do. We are an initiative that works to connect, support, and build freshwater initiatives across Canada. So we work with the nonprofit community, community groups, governments, businesses, First Nations, to strengthen citizen voices and participation to protect our lakes and rivers. We are a project on the Tides Canada shared platform. So just a few words of housekeeping here. We can hear you if you do not have your microphone muted. So if everyone would please go ahead and mute your microphone, that would be great. Then we just won't get feedback and we won't hear everyone. So if the little microphone is red and there's a line through it, that means that you're muted and you're good to go. If it's not, that means that we can hear you. So I'll do a pretty quick introduction here to our speaker and then pass it over to John. So John Pomeroy, Dr. John Pomeroy, he's a pretty busy guy. In addition to being a Canada Research Chair, a distinguished professor and director of the Centre for Hydrology at the University of Saskatchewan, he is also an honorary professor at Aberystwyth University in Wales. He's a visiting professor at the Chinese Academy of Sciences and an institute professor at the University of Calgary. And if that wasn't enough, he is also the director of the Global Water Futures Project, and that's the reason why he's here to speak with us today. So his current interests are in physical hydrology, emphasizing cold regions processes, watershed modeling, snow, forests, mountains, prairies, Arctic, hydrometeorology, hydrochemistry, ecohydrology, and instrumentation. And actually, John, I don't know if you would remember me, but I took your physical hydrology course in Kananaskis a few years ago, and I can tell you from firsthand experience that he's a pretty knowledgeable guy. So we're very lucky to have John on the webinar today to talk to us about Global Water Futures, what it is, what challenge their research teams are tackling, and how the freshwater community can maybe plug into that, opportunities maybe to partner with some researchers and get more involved. So John's going to present, and then after his presentation, we'll have time for questions and discussion. And there's a few ways you can do that. As questions come up throughout John's presentation, you can just go ahead and ask a question into the chat box, and then I'll kind of summarize all those up and ask and read them to John at the end of his presentation. And if you'd prefer, you can also unmute yourself and ask the question directly to John. Although it would be great if you could, before you do unmute yourself, if you could just ask me if that's okay if you do that first, just so we don't have about 10 people unmuting themselves at the same time. So without further ado, I will pass it over to John. John, I sent you a dialog box there to become the presenter. Have you been able to receive that?
Yes. Yeah, so hopefully we're sharing the screen now.
Yes, perfect.
Okay, great. Well, first I want to thank you, Christine, for inviting me. I do remember you as a student, and you're a good one, and it's always a delight to have the kind of continuing linkage, and delighted that you're working with Freshwater Alliance and continuing to. As Christine mentioned, I'm director of the Global Water Futures program at the University of Saskatchewan, which is in Treaty 6 territory and home of the Métis. And so I'll be talking about GWF with specific information that I am hoping is of great interest to the Freshwater Alliance, and some of those people will be on the webinar. So can you hear me all right, Christine?
Yeah, we can hear you great, and can see your presentation as well.
Great. Okay, so we'll carry on then. So anyway, what were some of the inspirations and the needs that created the Global Water Futures Program. One is always the unifying aspect of water for humans and their ecosystems. It's essential for life and society. Water is life, as many have said, and it influences every aspect of our economy, but also the ecosystems that sustain us, our cultural traditions, and
I'm just gonna go ahead and mute everyone on the line because we can hear some feedback from a phone call, which always inevitably happens on these. So I'm just gonna go ahead and mute everyone, and then I'm going to unmute you.
Okay.
Okay, I think you should be good there.
All right. Okay, great. Yeah, sounds better. So I'll carry on. So anyway, we are water, but we have issues with water. And in Canada, we think of ourselves as the water fortunate country with more storage and flow of water per person than almost anywhere on the planet. But remember that much of that water is in the north, and much of it is in fact being impacted because it's cold and we're undergoing rapid climate change. So we're seeing intensification of the hydrological cycle in some areas. Certainly you're seeing tremendous warming, but also Canadians have not been the greatest custodians of water. And so we have pollution events that result in algal blooms and toxic algae in the Great Lakes and in the prairies. We have agricultural management practices that may induce excess nitrogen, phosphorus runoff into our water bodies, and we have difficulty keeping up in our agricultural and forestry land management with the tremendous changes to climate that are occurring across Canada. And extreme wildfires is the manifestation of drought in the boreal forest and mountain forests, and the number of fires that we've had is increased dramatically, particularly in the last 10 years compared to previous periods. And of course, record fires in British Columbia last year, the year before that, the big fires in Fort McMurray, Alberta, the year before that, a complete evacuation of northern Saskatchewan, year before that, massive fires in the Northwest Territories. So these just carry on. Since the year 2000, we've had the worst drought overall wide swaths of the prairies in the settlement history of the region. And then just last year, a record dry period for parts of southern Saskatchewan and southern Alberta. If we look into across western and northern Canada, there's been tremendous warming, particularly in the winter. And if you go up to the Nunavik area, over 6.5 degrees of warming since 1960 for winter minimums. But this covers a large swath. That's the most severe. So what do we see? We see thawing permafrost causing infrastructure problems and ecosystem collapse and change, loss of forests in northern Canada. We see evidence such as glacier retreat in the Rocky Mountains and in the north. Glacier retreat so much that it's affected one of the major and important lakes in Canada, Kluane Lake, which received historically the outflow of the Kaskawulsk Glacier. And in 2016, that diverted due to the retreat of the glacier so that it feeds the Alsek River instead of the Slims River. And as a result, the Kluane Lake has dropped 1.5 meters in the summer. And that causes all kinds of changes to aquatic ecosystem. It puts the outflow at some risk. It's very shallow now. You can wade across it in just knee-high boots now in the spring. And then, of course, recreationally, the harbors and all other access for Indigenous peoples and tourists in the area are non-functional at this point. And then we've had flooding and droughts. The tremendous flooding that hit Calgary 25 years ago in 2013, causing $6 billion of damage. A month later, a few hours of heavy rain in Toronto caused $1 billion of damage. And then a summer rainfall-based flooding in the Canadian prairies in 2014 caused extensive flooding over areas that would never have it normally in July. So we're seeing lots of changes going on. And a question comes up, when we look at Cape Town and say, well, could Canada run out of water in some of our cities? And they say, well, we already have. We've had water restrictions already in Vancouver and the Lower Mainland and Vancouver Island and other parts of British Columbia because of low water supplies in the last few summers, almost a regular basis of lawn watering bans in southwestern BC. But we've also had water intakes restricted for Regina and Moose Jaw, Saskatchewan, because of toxic algae blooms in Buffalo Pound Lake. And of course, just across the border in Toledo, Ohio, a few years ago, they had to shut down the water treatment system for the city because of toxic algae blooms in Lake Erie. And so that, which is our shared water body. So we already have massive water problems and they're getting worse. And this proposes a tremendous challenge to us. We have to adapt to this combination of increasing development, increasing population, and climate change. And so we also have to mitigate the threats. And we know that this requires new science to understand the changing Earth system, as our 20th century approaches and techniques are simply not quite up to this. We know that we need new computer forecasting and prediction models that can bring together the biophysical, ecological, human, and economic forces and that govern our changing river basins and lakes. And for instance, Canada hasn't had a national flood and drought forecasting capability. We haven't run a single hydrological model across the whole country, even to assess what our hydrological cycle is, let alone what it might be in the future. So we need tools that can do this. And we're a big country, we're a rich country, but our population is small. So even though the second largest in the world, our small population means that much of Canada is inadequately monitored. We do not have enough sensors and technicians to measure the stream flows, the lake level, water quality, the ice cover, the temperature, and the changes in the watershed across our country very well. Many areas we do. Southern Ontario, Quebec, parts of the prairies, parts of British Columbia, generally the settled areas of Canada, the Maritimes are not too bad. But as we go into the sparser settled areas, or particularly to provinces that are less well off, so they can't make the contributions to the federal government to help in the monitoring programs, then the density is quite low and sometimes at developing world standards. And our monitoring systems tend not to be in certain places. We have about 4 or 5 stream gauges on First Nations in all of Canada, which is incredibly low. So things like that, the location of these gauges is sometimes something to look at. We have very few in the far north. And then finally, with scientific information that we might develop and already have, we need to find ways to get this out to the public in ways that they communicate now. And that means apps, computer games, visualization tools. We need to fine-tune scientific information for various user groups so it's in a usable form for them. So these are some of the challenges we have. So based on all of this, we applied to the Canada First Research Excellence Fund several years ago for a program we call Global Water Futures. And we suggested 2 large aims for GWF. The first is to place and in some sense perhaps restore Canada as a global leader in water science, with a particular emphasis on cold regions where we have our own local science, which has been world leading for many years. But we wanted to emphasize it a bit stronger. And you know what, I think we can do more than just cold regions in terms of our global leadership. The second is that CFREF program wanted projects that would address needs of the Canadian economy. And in this case, that's adapting to change and managing the risks of uncertain water futures. So so in response to the Canada First Research Excellence Fund call, they put $1.5 billion into science, which was remarkable in Canada. We put together a proposal, and ours was different from all the others, and ours was essentially a network. There were 4 primary partner institutions: University of Saskatchewan, Waterloo, McMaster, and Laurier University. But we had a total of 18 partner institutions, other institutions where particular faculty expertise could contribute to the program. And so there were another 14 across Canada added to that list, which makes us really a coast to coast, from south to north, and in terms of our breadth, and that's about 400 faculty eligible to participate in the program, which is quite unique and remarkable, I think, itself. We also brought in a tremendous partnership of, besides the 18 universities in Canada, 8 federal government agencies, the major natural resource departments federally, a number of Indigenous communities and First Nations governments, and many more than 7 that we were in contact with, but 7 were able to provide letters of support. And some of these, like the Federation of Sovereign Indigenous Nations, were collaborative groups. A number of provincial agencies across Canada, 34 industries, and then 45 international collaborative institutions from around the world. And sometimes these would be high-end research institutions in the United States and Europe and China. Other times they would be groups that were looking to deploy some of our information in other parts of the world. And then we also contribute to and tie into 3 global programs. One is UNESCO's International Hydrological Program. The second is the World Climate Research Program through its Global Energy and Water Exchanges Experiment. And then the third is Future Earth through the Water Futures component of that. So substantial international engagement as well. The mission that we devised for Global Water Futures is 3 parts. The first is to improve disaster warning. I was in Canmore, Alberta, when the floods hit in June 2013, and then watching that locally and in Calgary and High River, and then again in other parts of Canada. We could reduce the damages from flooding if we had better warning, and that means we really have to up our game to understand the generation of floods under a changing climate much better, and find ways to monitor and model predict these things. We also want to contribute to developing a national forecasting capacity to predict the risk and severity of floods and droughts. And in fact, we're on the way to doing that now. The second is predicting water futures and further into the future. So forecasting is a few days in advance, but we want to predict years, decades, centuries in advance. And this is using models and big data and the science information to start to assess that, well, in 50 years, 100 years, what will our water supplies and qualities be? How will we need to manage our water? What activities will be suitable to have that involve water in Canada? And so this is, of course, is diving deep into the questions of climate change and particularly how it impacts water cycling over Canada, but also looking at water use and management across the country. And then the third one, working with user groups. The third part is working with user groups such as yourselves and others to provide information to them to help them reduce the risks that they're undergoing, to help them design adaptations, to find new economic opportunities. The things we'd like to do in Canada, such as advise the improvement of governance of water, look at new policy tools, new ways to manage water. And so we're working with governments and other organizations to help them do that, with industry and others. So where are we today? We did receive the grant from Canada First. It was $77.8 million, which is the largest water research grant in Canadian history. We've used it to fund 33 projects. We set up an internal call for proposals, and the proponents had to go through a very rigorous evaluation process of an international peer review panel, letters of intent, and then full proposal. They were evaluated every year with respect to their progress, and so the first set of projects will run for the first 3 years of the program, and then we'll have a renewal in 2020. But anyway, these projects so far involve 15 universities, over 150 faculty members, and they've hired almost 500 researchers at this point. They've involved over 200 partners, so the partner group has expanded dramatically across Canada. And we've also established 6 core teams, and the core teams deal with aspects of modeling, knowledge mobilization, computer science, observations, or communications. And as you can see, the cash awards to the projects is $23.5 million, but they've been able to raise almost $27 million of cash. and they've leveraged in $120 million of in-kind support. And we've also put almost $15 million onto the core team. So this is very substantial endeavor. Some details, and I'm not going to read it off to you, but you can take a look at things in there that might be interesting to you. We have 21 of the projects are basic research, big data or decision support tool development from a variety of water-related topics, everything except water treatment technologies. And then 12 are user question-led projects. Our pillar 3 was really dealing with user question-led topics. Pillars 1 and 2. Pillar 1 is more science. Pillar 2 is big data and modeling. And so some of the pillar 3 projects are regional, like the Great Lakes or the North or the mountains. Some are topical, co-development of research questions with First Nations. Some are sectoral, such as agriculture. The core teams I mentioned, we have a tremendous core group of expertise that allows us to function as a program and getting things done. And this core team group also makes results available and technologies available to the projects that are running across. And we've been able to work with the federal government. Wonderful news is that the National Hydrological Service of Environment and Climate Change Canada has received funding for enhanced water observations and to develop a national water prediction advisory system. In Global Water Futures, we've implemented a flood forecasting system for the Yukon, a mountain snow forecasting system so far, and we've set up river basin models on the Mackenzie and Saskatchewan and the Great Lakes system at this point. And so I'll go into a bit more of that. The important aspect in our minds is to integrate water observation and prediction. And so these core teams will deliver that for us. Having 20 technicians out there allows us to have about 50 observation sites across Canada, some of which are very complex and very important sites to measure watersheds or glaciers or river systems or lakes, things like that, and have high quality technicians there to make sure we have good information. The development of computer models for prediction ranges from hydrology models to water quality models, climate change models. These models can be run in forecast mode or long-term prediction modes, and they tie into water resources modeling, bringing humans into it through reservoir management, through economic systems, through looking at the price aspects on irrigation demand and things like that. And then knowledge mobilization, including a team member from an Indigenous community, helps us bring this information out to the user groups and partners across Canada, as does our communications team. One thing we received funding for more recently is from Western Economic Diversification for the Smart Water Systems Laboratory located at the University of Saskatchewan. And we're using that to set up drones with hyperspectral cameras. That's what you see in the upper left-hand corner there. We are going to start deploying that over algae infested lakes. The hyperspectral allows us to detect algae blooms before they're very large and can help in predicting harmful algae blooms. And we'll be testing that this summer. On the right-hand side is a system for acoustic sensing of snow. This sends sound waves into the snowpack to allow us to measure the depth, density, wetness, and temperature of the snow, and without digging a snow pit, without grabbing a sample with a tube. And so we're developing this device and starting to produce them, and we would like to populate Canada with them. And then in the lower left-hand corner, you see part of the Canadian Rockies Hydrological Observatory. There's lots of instruments in there to figure out the mountain snowpack, which is so important for driving river water supply in Western Canada. We have an Indigenous community water research strategy, and this is something we co-created with the First Nations at a meeting in Saskatoon at Wanuskewin Heritage Park a few months ago. And this is involved regional workshops, project and core team engagement. We have a number of projects that have substantial Indigenous community work, and we have we're receiving I believe 9 projects proposals that we expect in September on Indigenous community water research. And the project proposal process was scoped out and co-created with Indigenous community representatives at the April meeting. We also had something very, very different. We worked with the Six Nations of the Grand River to have a First Nations Water Security and Climate Change Symposium that was there on June 3rd at Oshwekin, Ontario, and a number of very important keynote speakers and distinguished guests, and also presentations from Global Water Futures. So that was a very exciting thing. And we, in fact, had part of our Global Water Futures annual meeting hosted on the Six Nations. And I believe it's the first time in Canadian history that a major scientific meeting was held on First Nations territory. And so it was a wonderful experience, and one that I highly encourage to other groups, and we learned so much from it, and we'll keep working together closely with First Nations across the country through these initiatives. Internationally, Global Water Futures is working on mountain hydrology and hydrometeorology through INARCH. That's the International Network on Alpine Research Catchment Hydrology. We've applied for Global Water Futures as a regional hydroclimate project of the Global Energy and Water Exchanges Experiment, which is part of the World Climate Research Program. So that's called GWEX. We have partnered with UN University to form Canada Water, which is a strategy and action plan for outreach to help Canada address the UN Water Action Decade for Sustainable Development, which has just started. We're contributing to the Water Futures component of Future Earth, and we're helping with hydrological modeling and prediction in a variety of countries around the world now, from Iran to Israel to Kazakhstan to Chile, and working closely with China in their third pole environment, which is the high mountain regions of Western China, the Tibetan Plateau and surrounding mountains, and looking forward to exchanges with China on that. Now, I want to show you some of the results from some of the 33 projects, and I picked just a few to show you some of the things that would be interesting, that might capture interest. And one project is called Next Generation Solutions to Ensure Healthy Water Resources for Future Generations, and that's led by Professor John Giese of the University of Saskatchewan. And they're doing something very interesting. They're using environmental DNA to forensically analyze water using a DNA sequencer that we're able to purchase with GWF funds and mass specs. And so this means that from a small sample of water, you can look at everything going on in that system. And because these DNA systems, this allows you to get into sort of forensics on what's going on in your water, what has been going on in your water. And it also means you don't have to sample water everywhere along a river or lake system. You can just grab it at a few points, because that DNA gets released into the environment and you can collect it. And so you collect the sample, you extract the DNA, you amplify it, you sequence it, and you see who's hanging out in that water and specific species. And this is really good for invasive species, but also species will change based on environmental changes going on. So it allows tremendous detection of change in those water. And so the factors that might affect species, you can look at changes to aquatic communities and changes of their ecosystems as shifts occur, and then assess biodiversity in these systems. So that's a really exciting project. Another one related on lakes is called Form Bloom, and this is headed by Professor Helen Balk of the University of Saskatchewan. This is looking at harmful algae blooms, HABs, and various components. One is looking at adaptation strategies in the short term. Can we forecast harmful algal blooms, and can we communicate the risks and improve testing of these things? And then longer term, they want to look at nutrient controls, treatment sources, and interventions. So that's right now, improving risk communications, forecasting, and remote sensing technology, such as that drone I mentioned, to help manage risk. We're also looking at through the one of the sensors projects led by Claude Duguay to actually get a Global Water Futures satellite up there, which would be specifically tuned to look for harmful algae bloom emergence in lakes. So I think that would be tremendously important. Lake Futures is another large project. It's led by Professor Nandita Basu of the University of Waterloo. It's primarily focused on the Great Lakes region, and where there are tremendous developmental pressures in place. And they are working to look at the causes and impacts of lake eutrophication and develop models and indicators to help predict this and assess the management options in that area. And so what we expect is that they'll provide some solutions that will help improve the resilience and the adaptive capacity of Canada's lakes basins as the climate continues to shift and land use and pressure development continues. The Lake Futures project, looking at a variety of user needs from algal blooms to water quality to climate change adaptation. They have 5 work plans focusing on watersheds or impacts, cumulative effects, socioeconomic drivers, and integration of these things. And then the idea is that they'll transfer out that knowledge through a variety of things, from ecosystem indicators to decision support tools to maps and to forecasting systems. And so they link strongly with some of the other projects as well. And and some of these projects I won't talk about, but see the transformative technologies, the sensors, the lake ice modeling, winter processes. These are all projects in GWF. And some of the others I'll talk about. Form Bloom I have. We'll get into the Prairie Water, Ag Water next. ED&A I've spoken about already. Agricultural Water Futures is led by Mary McRae at University of Waterloo. It's works across Canada in the agricultural region and concerned with changes in crops as the climate warms, intensification of livestock, water quality at the end of fields, what kind of runoff is coming off our fields, impacts of tile drainage, and the expansion of the irrigation industry. So the goal is to determine how Canadian agriculture can best respond to changes and to look at water use, water productivity for crops. Water quality is a massive importance, and that's why I think it's very relevant to your group, and also to help with decision making on this. Prairie Water is another large project with dozens of members. Is led by Dr. Chris Spence of Environment Canada and Professor Colin Whitfield of the University of Saskatchewan, dealing with water in the prairie ecoregion of the 3 prairie provinces. And lots of water problems going on there: eutrophication of lakes, wetland drainage, groundwater sustainability, water availability and quality, and a lot of work on prairie sloughs and wetlands. Dealing with this very comprehensively, from surface water to groundwater to wetlands and to governance aspects. Some of the key outcomes will be predicting water availability and quality as the climate and land use changes on the prairies, assessing groundwater management, looking at wetland services, vulnerability and conservation, and then looking at ways to mobilize science and governance models with communities to improve resiliency. So it's a very comprehensive project. Some of the challenges they're dealing with: drainage of wetlands. This is in eastern Saskatchewan, areas that are drained and undrained during melt. And so there's a lot of water moving off these surfaces when they're drained. In Smith Creek, drainage has increased from 10%. The wetlands have reduced from 24% to 10% of the basin area, about 58% reduction. And drainage channels have increased 8-fold since the late 1950s. The result is you get that with some climate change and extreme events magnifies the size of the floods coming off of this watershed. And we see that the discharge volumes, the annual discharge volume in cubic decameters coming off Smith Creek has increased tremendously since the 1980s and 1990s. And part of that's climate change. It used to be snowmelt dominated, and now we're seeing a large rainfall domination in the outflows, but the volume of outflows has increased from all components so much that there's a wetland drainage magnifier on these outflows as well. So the combination of climate change and wetland drainage is really dangerous, and that's what's happening in parts of the prairies and contributing to the high flows. Just so you can see the shifts in the hydrograph, this is the stream discharge off of Smith Creek The upper graph is how it was from the 1970s and the 1990s. You get a peak around early April. In dry years, it didn't flow. In wet years, it was quite high. As we go down and look at the lower graph, 2011 to 2014, now we get two peaks. We get a midsummer peak in July that's driven by rainfall, and the volumes of flows are much, much higher now, and the stream really never goes dry in the summer. So that's complete hydrological regime change because of changes in land use, in drainage, and in climate over that particular watershed. These are the tremendous challenges that are being faced in the prairies, as that water is carrying nutrients, phosphorus in particular, nitrogen from agricultural runoff, and that ends up in Lake Winnipeg, the other big lakes downstream, and it's causing eutrophication problems. We have a large modeling project, which is having its meeting in third week in July, IMPC, and it's very comprehensive, from earth system modeling to water management modeling to decision-making systems and user engagement. So a very large, complex project with a range of scientists, from computer modelers to hydrological engineers to social scientists, which itself I think is quite unique. And that with our core teams and by the way, IMPC is led by Professor Salman Razavi of U of S, and the core team for modeling is led by Dr. Alan Pietranero of the Environment Canada's National Hydrological Service. Between the two, there are 2.5 or about 5 million square kilometers of watersheds will be modeled across Canada. And remember, these watersheds have hydrological observing sites scattered throughout them to help make sure these models are accurate and doing the job we need. One of the models being used is the mesh modeling system, which is somewhat modular. It brings in the Canadian land surface scheme with a hydrological model, and it can be driven by the Environment Canada's GEM atmospheric model. It can also be driven by future climate models, which is what we're doing right now. And it's been set up over the Great Lakes, over the Saskatchewan River Basin, and over the Peace, Athabasca, Mackenzie River Basin right now. And we're extending it. We've just set it up on the Yukon River Basin. So it's spreading across Canada, which is as it should be. Setting up a model like mesh over a river basin is a very complex process. We have to take into account the soils, the land cover, the river and lake network, the land surface topography, the drainage systems, and also how the water is managed. And in the Saskatchewan River Basin, of course, irrigation and water diversions are very important. And so we have substantial irrigation districts in southern Alberta, in the Bow and the Oldman, and we're in Saskatchewan around Lake Diefenbaker as a first example. Setting up the model, then we calibrate and validate it with respect to water management and use, and are then able to simulate the whole hydrological cycle over this basin. And so the map there you see with different amounts of colors changing, that's a runoff generation over several years of simulation in that area. So you can see the runoff's almost completely coming out of the Rockies or down in the Manitoba side in the southern boreal forest, and but also substantial variability from year to year. 2011, a very peak year there, 2003 being a drought. More recently, we have set up a similar model, the GEM hydro model, which is similar to MESH, and working with Environment and Climate Change Canada, set this up to simulate stream flows during events such as the 2013 flood in southern Alberta. And so this is a hindcast simulation of that using a high resolution atmospheric model, the weather model at 1 kilometer resolution. And I'll play it again here, but you can see there you go. You see the flood hitting on the 20th and 21st now, and then the flood waters moving their way to Calgary. What's unique about this model for Canada is that the small streams, the small mountain streams and lakes can be modeled with this system, which is not something that is normally done in a flood prediction model. So it's at a higher resolution and capability than we've ever had in Canada before. And we want to run this out across Canada and make these models and their outputs available to the provinces, to the First Nations, to cities, and anyone else who wants it. So So that's a very exciting development. So GWF had its inaugural meeting in early June of this year, over 4 days at McMaster University in 6 nations of the Grand River. As I mentioned, it's the first time a national scientific meeting met on First Nations territory. Over 400 people from across Canada, with invited guests from the UN and World Climate Research Program and Future Earth. Over 160 presentations from a wide variety of people for that meeting. So it was just a wonderful atmosphere there, and very dynamic and excellent science already showing up. The grand challenge we set for ourselves when we some time ago is how can we best prepare for and manage water futures in the face of dramatically increasing risks from changing climate, developing economy, and changing society. And I think we're on target with this challenge. And our statement that we adopted in June of this year is that we've met as a whole for the first time. We've brought together a large and comprehensive transdisciplinary group of water researchers and stakeholders, and we brought together our progress and shared our progress in meeting that grand challenge. It was very comprehensive for the subjects represented, more so perhaps than any other water meeting in Canadian history. We have early and rapid progress because we're able to build on lots of wonderful existing programs, such as the Changing Cold Regions Network and the Canada Water Network and others. And we had hosted in co-organization with the First Nation. And we address international linkages, our regional and topical advances in Canada, co-creation of knowledge, setting up the young professionals group and having them run parts of the meeting, and then also integrating research needs and science and technology on 5 topics: modeling and observations, the aquatic environment and ecosystems, human-water interactions, watershed management and disturbance, and climate and extreme weather. We're pulling that information together. So if you're in Saskatoon or Canmore, I encourage you to drop in, visit Global Water Futures, learn more about us. And if you're close to a computer, you can look it up on the web at globalwaterfutures.ca. But anyway, thank you so much, and hope there's time to answer a few questions.
Great. Thank you so much, John. All right. Well, that was a lot of information, and hopefully everyone was able to take some of that in. We are now going to open it up to discussion. So if you have questions for John, if you could either ask, just let me know in the chat box that you'd like to unmute yourself and say it out loud, or you can just put it right into the chat box itself. So John, maybe I'll start with a question. And there seems to be a bit of construction going on in my building, so hopefully it's not too noisy for everyone else. But I'm wondering, we have a lot of people on the webinar who work for nonprofit community groups and environmental organizations. And what are some ways that, maybe these organizations could, either partner with researchers or find more about individual projects, or because I think a lot of the research that's going on will definitely support some of the missions and work that are that folks in the webinar are doing. So I'd love to hear a bit more about that.
Yeah, there are multiple ways to partner with Global Water Futures, and one, it may be one or more of the 33 projects may be of particular interest to you, and you can find those projects described in detail on the website. The larger projects have knowledge mobilization officers, and but they all have contact information, and they're looking for users to work with. They're mandated for transdisciplinary research, which means conducting research with users, and they have some on, but they don't have everyone, and so I think they'd be delighted to hear from you. The second is at the Global Water Futures level itself. At the program level, there are some things we're doing that are that would have general interest and significance, and so we encourage linking up to members of our knowledge mobilization team, Stephanie Merrill, some of the others on that, and making sure that we can get information to you and hear of your concerns at the program level appropriately. We also have adopted something new that the call's not out yet, but you can watch for it. And this is opening up Global Water Futures for affiliated projects. So let's say you have a research project and you would like it to become affiliated with Global Water Futures. There'll be a way for you to do that. And because we can't cover everything, and but we'd like to embrace a broader range of research and partnerships and researchers across the country. And for these affiliated projects, we'll have arrangements to share model outputs or other data outputs and aspects of knowledge mobilization and participate in the annual meetings in various ways. And then also the annual meetings are another way for participation. And when the calls go up for those, if you'd like to speak at them, put together an abstract and a title talk, and we'll try to get you up there. And I think many of the sessions we had in the last one, we had them all led off by a user or outside organization to express their concerns and issues before we got into what Global Water Futures had. And that'll be our continuing model.
Great, thank you. Thanks, John. So it looks like we can go on the website, see what projects are on there and contact the heads, or maybe also I can follow up with Stephanie and she can let me know about ways that we can connect with different projects as well.
Yeah, and if you just have a general inquiry, send it to gwf.project@usas.ca.
Sure.
And we'll make sure it gets to the right person.
Great. There's a couple more questions, but one is more directly related to the question that I just asked. So I'll get to that one first, and then Ian, I'll come back to you. So Andrew asks, if we wanted to reach out to Global Water Futures to determine if there is a good fit to collaborate or be affiliated, who is the best person? So I think that might be actually what you just said, John. So is that just to email GWF at, say, if you could say it again?
Yes, it's gwf.project@usask.ca.
usas.ca. Okay, great. I just put that into the chat box there, and then I will also send that out to everyone, as well as a link to the recording of the webinar later on. So then we have a question from Ian, who wants to know, he says that there appears to be little integration of groundwater into the Global Water Futures focus, and is wondering a bit more about why so much focus on surface water and ostensibly maybe not so much on groundwater.
Oh, I disagree. There's lots of groundwater in Global Water Futures. It's a component of most of the big projects, the regional ones, whether it's Great Lakes or the prairies or the mountains or the north. There are specific groundwater projects. One is looking at cross-contamination between shallow and deep groundwater in southeastern Saskatchewan, an area where there's substantial unconventional oil and gas activity. And others are looking at it in the context of changing permafrost in the north, per se. We're also working and developing a stronger relationship with Natural Resources Canada and their groundwater group, and they have projects that we're linking to. For instance, we conduct a lot of work on the Peyto Glacier, and they want to look at the groundwater connections of Peyto Glacier. We also have scientists such as Masaki Hayashi involved, who's looking at groundwater in the source waters of the Rocky Mountains for many of the watersheds. And a particular interest there is that what will the stream flows be when the glaciers are gone? And those stream flows, the low flows, of course, are groundwater driven. So there's lots of interest there. And even when we're talking about drought, that often means we're talking about groundwater, for instance.
Great, thanks for clarifying that, John. No more questions in the chat box for now, but a question that I have is, there's so much going on, so many different researchers, so many different projects, that I suspect that it's generating a massive amount of knowledge. And I'm wondering if Global Water Futures has any plans to try to be able to integrate that and communicate, maybe like a state of our waters report, or, how do we kind of communicate the big takeaways from what all of this research, a lot of very technical, a lot of very, regional and place-based research, what that means globally, or at least for Canada? Are there any plans of kind of integrating all of these different facets to communicate that in a more general or sweeping kind of way?
Yes, we are, and that's a big effort of the program. So every year we have to report to Canada First Research Excellence Fund on a variety of indicators, including a broad assessment of what we're doing, what we're finding, and that whole report ends up almost 100 pages. So we're taking that information and starting off with what we're calling an inception report for Global Water Futures, which will be a big one. And this will be the details of what all the projects are doing, how they're approaching it, and what they expect to find for both the projects and the core teams and the network as a whole. And so that we're developing right now. We'll make it available over the summer. And then we'll also make our progress report available every year with more details on what we're doing, but also distilled down to some of the major findings. And yeah, it's so wide ranging. It's challenging to encapsulate that into a paragraph or a few sentences, but we're certainly going to try. And the basic message is that our water is under threat in many, many different ways, whether it's pollution or changing climate or extreme events. And we're starting to make some progress in being able to predict it a bit and measure this a little bit better. And but also we're trying to bring different levels of government and communities to the table in a different way, because the solutions will have to be ones that bring in all Canadians together to solve this. And final thing is that many of our river basins are transboundary and shared with the United States, and so our international relations on how we protect and conserve our water bodies are critically important, and something we need to start to focus on a bit more in the future. We can't do this alone.
Absolutely. Oh, that's great. We'll look forward to seeing that Inception report this summer and the progress reports as well. I have another question that's just come in from Emma Waddy, who's with the Atlantic Water Network. And she says, what a great project. It's very exciting to see the diversity of perspectives and topics, as well as the intentional partnerships with Indigenous partners. And then she's wondering that, there doesn't appear to be very many active projects on the East Coast. And she wants to know if there are projects that might expand to work in Atlantic Canada, or maybe some opportunities for research to be applied there, especially in light of the flooding in New Brunswick this spring and Cape Breton.
Yeah, that's. This is something we're aware of. I think we're weak on the east and west coasts on the extreme coasts there, and we're also weak in the high Arctic, and so right now we have a focus. One focus is on the St. John River Basin, and working with the Canadian Rivers Institute there to get the models set up and some assessments in that area. The Agricultural Water Futures Project has quite a bit of activity in Nova Scotia from some runoff databases. And of course, the Boreal Forest Project does run coast to coast like that. But we want to increase activity on the far east coast. We have no Newfoundland presence whatsoever, for instance, and which is something I would like to correct in the future. We also need to do more on Vancouver Island and the far west coast. So in the phase 2 of Global Water Futures, we will start to change the partnership a bit and try to open it up, particularly to university-based researchers in regions that we haven't managed to work with so far. And we've encouraged our projects to start to change their geographic scope to a pan-Canadian focus so they can cover all of Canada.
Great, thanks, John. And maybe that sounds like a bit of an invitation to Emma or other folks in the East Coast as well to be in touch if they'd like to make some partnerships.
Yes, we would like to talk to you and find out your concerns and find out how we can best address them in the future. And we're very keen on that. The renewal of the program is in 2020, and then the projects will have a second phase, and this is where we can start to then deal with some of those concerns.
Perfect. All right, I think we have time for one last question. And so we have one from Oliver Brandis at the POLIS Project on Ecological Governance at the University of Victoria. And he is asking, on this theme of integrating and complementing other initiatives, I'm wondering how Global Water Futures relates to the work done previously by the Canadian Water Network. Are there programs that you're building on and summarizing or mobilizing knowledge of some of that work to date?
Yeah, well, we have a lot of the researchers that were in the Canadian Water Network involved in GWF, Mark Servos, for instance, and many of the groups at Waterloo and across the country. They're different networks and they have different focus, of course, but there's lots of interest in source water protection and water policy and other things that we're keeping going there. And then we also have taken their model for knowledge mobilization as an example for how to do it best in global water futures. So yeah, we're trying to tie into that legacy very, very strongly and build across that in Canada through linking with the same people, and some of the projects are certainly follow-ons from some of the big projects in Canadian Water Network.
Great, perfect. Well, that sums up all the questions that we have, and we are coming in just a couple of minutes before the hour. So I just want to thank you very much, John, for joining us today and sharing your knowledge and work with Global Water Futures, and thanks to everyone who's able to join us. And I will follow up with some of those resources to everyone that signed up to the webinar, and with ways to be in touch and what have you. So thank you so much, John.
Well, thank you. It's a delight to speak to your group, and we hope to hear more of you and see some of you at our annual meeting. I think next year it's going to be in May and in Saskatoon. And we don't have much more sorted out than that at this point. But anyway, that's a lovely place to be at that time of year. So we'll hope to see you there.
All right. May in Saskatoon, everybody. Mark your calendars. All right. Thank you so much, John.
Thank you. Bye-bye.
Bye-bye.